So in the first example, right, and most of the time when we encounter these problems, most of the time they are written like this, right? They're in what we call standard form for a straight line. AX plus BY equals C. The X's are lined up and the Y's are lined up and the constants are lined up on the other side of the equal sign. And you look at them right away and say, by chance, are the coefficients of one of the variables opposite numbers? Yes, they are. 2 and -2, which means that first step is not necessary. So the second step is add them up. Add up the X's, add up the Y's. But because the Y's have opposite coefficients, they cancel. And add up the constants. So by taking that step, we eliminated the Y's, right? That's why it's called elimination. So now we still have to solve. X equals 12 over 8, which is 3 over 2, or 1.5, whatever you want to say. Okay. Now, you have a choice where you want to find Y. Do you want to plug the X in here or here? It doesn't matter. You're going to get the same thing. Top. You know, normally, I would have gone to the top because I don't like the coefficient of -2 there. Just one more chance to make a mistake. But it doesn't matter. If you're careful, you'll get the same answer anyways. So we're going to plug in this X here. And that will give us 3 times 3/2 plus 2Y equals 4. 9/2 plus 2Y equals 4. Right, so now we've got one equation, one variable we can solve. You don't have to, but if it helps you, you could multiply everything by 2 to get rid of the denominator. Right? I would say that's probably a good idea, but if you want to just make that's 4.5, right? I mean, yeah, if we turn this into, let's do it that way this time. It doesn't make any difference. So I'd say this is 4.5 plus 2Y equals 4. Now when I subtract, I get 2Y equals -0.5. And then I divide by 2, and I get -0.25, which is -1/4 as a fraction. So it doesn't matter to me whether you make it as a decimal or a fraction, or whether you clear fractions by multiplying by 2.